Hey guys, this is Mark. In this video, we will continue the discussion of the many-to-many relations that we started in the previous video. And to pick up from where we left off, the design that we had, the database design that we had reviewed in the previous video was based on the one-to-many relations between the parent and child tables. And with the bidirectional nature of the relations, that one-to-many really turns up to be a many-to-many relation. And more details about that in the previous video that I recommend you to watch if you haven't done so, in order to fully understand what we're going to be talking about in this video. So the design problem that I mentioned in the previous video was that in the approach where we use one-to-many, if the relationship itself has any properties, then there is really no room to express those properties. And the sample schema that we reviewed consisted of the course and student tables. And as a result, information about the actual student enrollment and the side effects of that enrollment, such as getting grades or making payments or whatever, is there to represent the actual course and student relationship. There is really no room in schema to identify properties of the actual relations. For instance, let's focus on grades because the concept of a grade for a student and a specific course is very representative to highlight that problem. So now let's task ourselves and say, how can we go about changing the design where we now have room to express that additional information and capture it in the database? And the classical design for many-to-many relations, and that's the one that we will adapt in Backendless, consists of three tables. So there is a table course, there is a table student, and there is an intermediate table that describes the actual relationship. And that's exactly what we are going to do and review in this video. Is an approach where we have three tables, course and student, just like we had before, but we will introduce third table that contains references to both course and student. And now that we have references and records in representing the actual relations, we will have a perfect place to bring additional data about the relationship, such as grade or the date of enrollment or the date when the student may have dropped out. All of that would be captured in that intermediate table. So let's take a look at how that design would work. So it is actually fairly straightforward because in this case, we could use one-to-one relationship from students and courses as they relate to course and student tables. So every single record in students and courses would have two relationships. One relationship would be one-to-one to course, and the other relationship column would be one-to-one pointing to student. As a result, a single record in students and courses would represent an enrollment of a specific student in a specific course and would contain data about that enrollment, such as grade, for example. So with this, then we basically get this sort of a network of relationships that really represent what students are enrolled into what courses. And just visually alone, by looking at this diagram, it would be very easy to kind of trace down. For instance, if we take that student right here, then we will see that it has two relationships coming in from students and courses. These are the records. And then these two records then point out to these two courses. So we know that this student is enrolled in these two courses. And if we can trace it visually and we know there are relationships there, absolutely, we can describe it through, let's say, where clause, and just using the Backendless notation that gives us an ability to trace data from one table to another. We will certainly be able to do that. And likewise, if we start with a course, and let's say take this one, then there is an incoming relationship from this table, and then outgoing into student. So we know that in that course, we have that student enrolled in there. So just with this bidirectional nature, it gives us complete control to be able to start expressing queries and capture the information that we need for various conditions. So how will it work? And this is going to be more of a repetition of what we already talked about, but really in the context of that specific database design. So first of all, there will be a table called course in students and courses, and there will be a relationship column called course in this table, and the relationship column called student. Okay, and they are going to be one-to-one relationships pointing to the course and student tables. Likewise, with the bidirectional nature of the Backendless database, then we get this pseudo columns in both course and student that point back to the students in the course. Okay, so while these relationships are one-to-one, the ones that are reverting back are going to be one-to-many. And that's how the actual many-to-many relationship between students and courses becomes possible. Okay, so with this, let's review exactly the same use cases that we had reviewed in the previous video and see how they would work. Now, before we go any further, let me demonstrate what that actual table looks like. I do not have a file to import, but the table is so simple where you can actually reconstruct what you will see now in your database and start playing with all of these queries that I will demonstrate in your application. So let's take a look in Backendless Console what that students and courses table would look like. So I am in Backendless Console, and as you can see, I already have this students and courses table. You do not need to remove anything that you already had. We just leverage that, and I know that both student and course tables, they're pointing to each other. That is okay. We will not be using those relationships, and if you'd like to get rid of them, get rid of the relationship columns in student and courses table. But go ahead and create the students and courses table, just like I have here. And the schema for the table is very, very straightforward. So I created a relationship column called course with a one-to-one relationship to the course table, and there is a column called student which is a relationship column pointing to the student table. And I also created a column called grade just to demonstrate how we can get a hold of grades or use them in various queries. I also populated this table with various relationships both for students and courses. By the way, the reason I have these names showing up in the relationship columns is because for both of these relations, what I did when you create that relation, or if you were to edit it, in here in the identification column, I identified the column that will be used in Backendless Console to visually represent the actual record that this relationship is pointing to. So it is name for course, and it is also name for students. And as a result, you will get something very similar. So I suggest that you replicate this in your application, populate it with data using Backendless Console. Just pick and choose individual students and courses, and you will have almost identical setup that I have now. So let's go back to the use cases that we have already previously reviewed with the previous design and see how they change with this three-table design for the many-to-many relations. Okay, so let's say that the use case is we need to get all students for a course. Since we are getting all students, then the actual query would need to be sent to the student table. And then to get all the students for a course, we need to reference a specific course in our query. How do we do this? Well, we start with a column that is already in student. It is the pseudo column students and courses with student in square bracket. Okay, so this, just by having this in the word clause, gives us a reference to this intermediate table. And then from the intermediate table, we have a column called course. So what we do is we take students and courses with student in square brackets dot course, and that points to the course table. And now that we have a pointer to the course table, we say dot name, and then we can put the name of the course for which we want to retrieve students. So our where clause query is going to look like this: students and courses, student, that gives us a pointer to this table. Then we say dot course, which is this column. That gives us a pointer to this table. And then we say dot name, which is basically the name of the course that we're looking in here. We give it a specific name, and that will bring back all the students that are enrolled in that specific course. So the most important thing here is think about the where clause when you structure it with this multi-dot notation, is that every part of that where clause is like a hop throughout your schema to the next table where you want to perform the actual search. So the first part we hop into here, then the second part we hop into course, and then the final dot name is the property in that final hop that where we will need to perform the actual query. So since it is just a where clause, then the codeless version will look like this, where you put this where clause and it will bring back all the students. The same where clause would be used across the board with all our SDKs because it is just a string. So I will not spend any time doing this in Backendless console because I want to try to keep this video as brief as possible. You're welcome to try it out and see how it works. I verified it, it does. Let's move on. So getting all courses for a student, it's going to be exactly the same approach. So if we are getting courses for a student, then the query needs to be sent to the course table. And in the course table, using again this hopping methodology, we use this pseudo column students and courses course that gives us puts us into this table, and from here we use dot student that puts us into the student table, and in there we can say dot name equals George or David or whoever, and that will give us all the courses for a specific student. So once again, pseudo column in here, hop into this table, dot student, which is the column in this intermediate table, puts us into student, dot name is where we run the search in the student for a specific student. So that gives us all the courses that David is enrolled. Again, with the codeless version, you just put the where clause, send it to the course table, and that's going to give you all the courses for a specific student. Actually very straightforward. Once you understand how to structure that where clause, which I believe is quite simple now that you understand the notation, I think it gives you the ability to run more powerful queries. Let's continue. So getting courses sorted by student enrollment. And this is something that we reviewed in the previous video. So in here, in order to get courses sorted by student enrollment, we need to know the student count. And in order to get the student count, we need to use the count function, if you remember. So we're gonna, for every course, we need to count how many students are there. In order to count how many students are there, we don't really need to go all the way to the student table, because if we take a look here, okay, the number of students that are enrolled in the course really is the number of these pointers coming into course. So what we need to do is to count how many objects are in that intermediate table that are pointing to each and every course. And that's where we use the count function. So here, what we are going to do is send a query to the course table because we are getting courses. And then in the properties, we do the count of the actual records in that intermediate table for every single course. And then the way this works is you use count and you identify the object ID in the intermediate table and just give it an alias, let's say student count. So that will give us how many objects are in the intermediate table that correspond to each individual course. With group by object ID, we're grouping those results by each individual course. So there is really no grouping. We just basically say every course stays with its own data and includes the student count. And as a result, then we can just do sort by student count, which is this dynamic property, and that will give us all the courses sorted by student enrollment. This is not any different than the approach that we reviewed in the previous video. The only difference is that in here, we do not go all the way to the student table. We just work with the intermediate table because it already has the information that we need. This one is getting students sorted by how many courses they are enrolled in. Again, it's exactly the same approach conceptually as in the previous use case. In order to see how many courses a student is enrolled in, we need to count for each student the number of these references coming into student from the intermediate table. And again, for this, we use the count function to see how many objects are there, related objects for every student, and then sort by that number. So that's going to look like this. So we take count students and courses. We count the number of those related objects. We record it as course count, a dynamic property, and then we sort by course count. Of course, it is very important to group by object ID. So each and every student remains as a separate object. And that will give us this result. Let's continue. Getting courses without any student enrollment. That is also very simple because here we just need to take all the courses that do not have incoming relation from the intermediate table. Okay. And the way this would work is we say students and courses, course, this pseudo table, dot object ID is null, meaning that give me all the objects that do not have an incoming relationship. And that will give us all the courses that have no students assigned to it. Basically, there are no records in the intermediate table. And then with where, since it is a where clause, the retrieval is nothing but using this codeless block with that where clause or using that where clause with code. Finally, getting students not enrolled in any courses. Again, we need to find, in this case, this block because it does not have an incoming connection. And here we use this pseudo column and we say students and courses, student dot object ID is null. And that will give us all the objects that don't have incoming references. And then with codeless, you just put that where clause in there. What's cool about this approach, and this is something that I don't have in these where clauses, is that with pretty much every single example that I demonstrated, you can start bringing data such as the grade for a specific student and the specific course into the response. Or you can use grade in the where clause. So you want to find all the students that are enrolled in biology and have grade greater than certain number, then you just basically say dot grade greater than 3. I will quickly demonstrate this just to give you an idea, but I will not go into all the different types of permutations, but you will see that it's actually very straightforward. So let me switch to Backendless Console for that. So now we are in Backendless Console, and let's say that we want to find all the students that are enrolled, for instance, in biology and have grade greater than 3. So in here for this, since we are retrieving students, let's switch to REST console. And in here, what we will do is first build the where clause of getting the students that are enrolled in biology. And for this, we will do students and courses student dot course dot name equals biology. Click get, and then we have 3 students. Now, how do we add grade information for every student? So we will add grade information, and then we'll modify the where clause to filter out only those that have a certain grade. So for this, we can request a specific property, and that will be students and courses student dot grade as grade. And then we will add star just to keep all the other properties. Click get, and now you can see there is a grade property that that we have for that student and the course that they're enrolled in. Well, in this case, the course is biology. And then if we want to filter out all the students, and as you can see, the grades are 4, 4, and then null. So David does not have a grade in biology yet. And then if we want to say that the grade give us all the students where the grade is for, what we can do is we say and students and courses student dot grade equals 4. Click get. So now we get these two students where the grade is 4. Something that I want to try, since we have grade as a property defined as grade, I wonder if we can just use that dynamic property like this. Let me give it a try. Yes, we can. So if you define a property and you give it an alias, you can use that alias in the where clause. And just like that, you can start incorporating other properties that belong to the actual relationship. In this case, I have on the grade in your where clause and in the properties that you define, which makes this particular design approach way more powerful than the one that we reviewed in the previous video. I hope you find this useful, and there are a lot of different variations where this three-table design it could become useful. And if you are struggling with this, or you need help with designing your queries and something just doesn't look straightforward or challenging or confusing, please let us know. For simple feedback about the video, please use comments in the for the video. For more technical questions, such as what should that query look like, or I'm getting an error, and so on, please post your questions to our support forum, which is support.backendless.com. And reference the video and say, look, I'm doing this and this, just like shown in this video, and things do not seem to work, and we'll be happy to assist you. But for now, thank you for watching, and as always, happy coding.